Here we go with section 11.4, identifying parts of solids. So, with these guys, we're going to be talking about polyhedrons. These are 3D figures. Made up of sides, or what we call faces. No curves. Okay. So polyhedron would look like, we could have a box. Oh, that was not a good 3D figure. We could have a pyramid. What else could we have? Those are kind of the main ones. I mean, you could have a trapezoid, a triangular pyramid. But none of these. You cannot have a cylinder or a sphere. Okay? That's a circle. Wow, that's not a very good sphere. Because these guys have curves, these guys do not. I guess we could also put a cone in there. Can't be a cone. Okay? Now, parts of a polyhedron, you're going to have edges, vertices, and faces, okay? So I'm going to use my triangular pyramid. I'm sorry, my rectangular pyramid. Okay, so there's my pyramid. Now, the points are called vertices. Or a singular would be a vertex. The points. So 1, 2, 3, 4, 5. Those guys are all vertices. Okay, all those guys are vertices. The points right here. We also have an edge. These are like the, what can I call it? Like a long corner. Like this is an edge right there. Okay. Can I say long corner? It's where two faces meet. Okay. So you also have an edge right here, edge right here, 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 here. Okay. And a face is like a flat side. So this guy has a face right here, face in the back, face on the side, face on the bottom. Now one thing to note is that the base can be the bottom face or the unique face. Okay? The reason why I say it, sometimes it's bottom, sometimes it's not. I mean, with this problem, we know that the base is this whole side on the bottom. That's the big B. Big B, that's the area of the base. Not to be confused with the area base. This is a three-dimensional shape base. Okay. Unique face. You could also, if you had something like this, that's a triangular prism. We'll talk about that more tomorrow. You might be like, oh, the base is the rectangle, it's on the bottom. No. The unique face, that'd be the triangle. Okay, the triangle would be the base in that particular problem. Okay, so base doesn't always mean bottom. It usually means bottom. Not gonna lie about that. But it's not always bottom. It's a unique face that the whole shape is kind of based on. Okay. So there we go. So we've got edges, we've got vertices, we got the bases, faces. Remember, faces are sides. Other things for this section we gotta look at. There's one thing called a cross section. Okay. There's a lot of names in this section. A cross section. It's the shape you get. It's a 2D shape that you get from a slice of a 3D shape. Okay. So it's a 2D shape you get from a slice of a 3D shape. What does that mean? Good question. If you have a cone and you took a slice right here, you're gonna just, or I mean, like, I don't know if you guys ever watched those cartoons where someone's wearing like a wizard hat and it gets sliced somehow, and then they lose the top of their hat. Well, what shape is left over on top? Well, it looks like a circle. Okay, so a cross section would be a circle. I am going to go over these a little bit in the examples, but that's about like kind of the best I can think of. Cross sections are if you ever do stuff with cooking, you know, like if you cut an apple in half, you've got like the two halves you pull apart. There's like a specific shape, not quite a circle. If you cut a banana, if you cut banana in slices, you're gonna get like these little circle things, right? So that would be like a cross section of a banana. Cross section of strawberries, those are harder to do unless you have a strawberry slicer. But again, you're cutting your shape and you're picking a shape out of something. Like this thing, I guess if you sit and think about it, this is made up of small circles that keep getting bigger. So there you go. But we will practice those ones. And the last thing you're gonna see on IXL, this is solids, like basically solids of a resolution, like what do you want to call it? Oh, revolving solids. It's something like revolving solids. Forming a solid by revolving and forming a 3D solid by revolving a 2D shape. Okay, so again, we're jumping into the three-dimensional plane here. And again, the easiest way to do these is probably just to do some examples with you guys. But just for your notes, I'll give you one. So kind of an example might be like this. Hey, if you were to rotate this what's it called? This rectangle, what would you get? Well, if you were to rotate this guy around this line, get a shape kind of like this. One thing I want you to note is you're going to get circular shapes here. Why? Because you're rotating. And rotating is a circular movement. Oh, I'm kind of messed up on that. Anyway, but this would become like a cylinder. Okay? Be a cylinder. Another example, we can do it the other way too. What if I was to do let's do a fun one. I don't think this is in your assignment. But if you were to rotate this guy, like these guys here wouldn't really move when you rotate them. But these guys would. They'd make a big something or other. Then you'd kind of have a situation like that. Boom. So you'd have like this weird hourglass shape, or eyeballs. Can we turn this into eyeballs? Probably could. Hey. Probably should have colored in his eyeballs there, as opposed to off to the side. Anyway, that's kind of the deal with forming a solid made by revolving a shape. To be 100% honest, you won't see this anymore this year after today. You may see it in trig, I don't know though. It depends on your teacher. You will see it in pre-calc. So if you're not going to pre-calc, it's like, it's something fun to learn. It's not too bad. Give the practice problems a shot. Let me know if you have any questions. Thanks for watching. Have a good day.